Alright, in this video we're going to be going over the warm-up. The warm-up is going to cover how to make a Maclaurin series given what we talked about last class. Last class we discussed some memorized series. We derived sine of x, cosine of x, e to the x. Notice some patterns in them, such as that cosine of x is all the even numbers, sine of x is all the odds, e to the x is all of the terms where the derivative goes to 1, so that the coefficients are just your standard Taylor coefficients of 1 over n factorial. When I first look at 1 minus cosine 2x over 2, I actually thought about our last unit and thought about, well, isn't this just equal to the sine squared of x? And then I realized that sine squared of x is not so good to expand, and that's not what we want to do here. But instead what we can do is expand the cosine of 2x. In order to expand the cosine of 2x, we can start by writing down the expansion of cosine of x. Now the cosine of x is going to be all of the even terms. So 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial minus x to the 6 over 6 factorial, and so forth. Now, in order to make it a cosine of 2x, what we want to do instead is replace all these x's with 2x's. The cosine of 2x is the exact same thing, except you substitute the 2x in. The usage of parentheses here is very important because if you were to simplify, you'd want to make sure you send the 2 to whatever the n power is in each series, or each sequence of the series, I guess, each term of the series. From this point, we can then recognize that we want to do 1 minus our answer. And in order to do 1 minus our answer, we would want to think about it like 1 minus the whole thing. So that would be the same as saying like 1 minus this whole thing. Now when you do 1 minus, it's pretty clear to see that these first two terms are going to cancel out. So that means 1 minus the cosine of 2x is really just negative 2x squared over 2 factorial plus, oh, actually, hold on. We want to distribute that negative. So once those ones cancel out, so I'll go back a couple lines. Although we are canceling out these ones, we want to remember to distribute our negative to all the terms. So this is 1 minus, and then in here we had the original parenthesis 1. So now that we're distributing this, we can recognize that yes, these are going to cancel out, but this minus must also be applied to all of the other terms as well. That's going to give us instead that 1 minus the cosine of 2x is equal to the quantity 2x squared over 2 factorial, and then minus 2x to the 4 over 4 factorial, plus 2x to the 6 over 6 factorial, and so forth. So this next one would be minus. It wants the general term as well, so let's go ahead and come up with that. Before we come up with the general term, we can recognize that all of this is over 2. So that means we just want to go back here and put like 2 times in the denominator of all the terms. Okay, so now to come up with the general term of this series, we can recognize a few things. Let's just start by analyzing like this first one. Notice that we still have all of the even values up here, and those even values are down here. So we can tell that it's still 2 to the n business. Specifically, it's 2x to the 2n over quantity 2n factorial. And the only thing that looks different is the fact that we have a 2 in front, so we just want to add another 2 in the denominator. Now, the last thing that we want to note is that as written up here, this guy represents the sigma, or like the first term of the sequence being n is 0. Now, because that term canceled off, that most likely means that in order for our general format over here to generate the first term in the sequence over here, in order for these to be connected, we need to think about what value of n do we plug in on the right so that we get this value on the left. And the answer is n is 1. The reason why we know that we have to plug in n is 1 is you just kind of look at the values inside. So we have a 2 factorial and a 2 up there, so that means that n starts at 1. So effectively, what we did is when this term canceled, we canceled the 0th term, meaning that now n starts at 1. So I know it doesn't ask, it asks for a general term, it doesn't ask for a sigma, but if you wanted to make it into a sigma, what you would do is copy this thing here. So you'd copy this guy here, and you could place that with a sigma, and that sigma would be from n is 1 to infinity. And that is our kind of final answer. It didn't really quite ask for that format, but I do think that format is very powerful. All right, for the second one, we could do each of these out, but I do think there is a bit of a strategy here that can make your life a lot easier. We see a 4, 5, 6, and it seems like it picks up every single term. Now, because it's picking up every single term, I claim that we can eliminate 3 of these answer choices. So it's picking up every single term, 4, 5, 6. That includes evens and odds. And based on that, I claim that we can eliminate 3 of these answer choices. The 3 choices we can eliminate are the trig ones. We can eliminate the trig ones because the cosine or sine will only produce odds or only produce evens. Even when manipulating them, they will still end up as only odds or only evens or some version of that. For example, I will show this cosine of x squared one out. So the cosine of x, as we stated up here, was 1 minus x squared over 2 factorial, x to the 4 over 4 factorial, x to the 6, 6 factorial. If we go and replace all of those x's with x squared, what you notice is they're going to get even further apart from each other. So the cosine of x squared, just the cosine of x squared, is going to equal 1 minus x squared squared plus x squared to the 4th. What you should notice about this is that we have these terms being very far apart from each other. If you simplified, this would be x to the 4th, this would be x to the 8th, the next one would be x to the 12th. Now, making it negative and adding 1, sure, that might eliminate this term, and it does, but there's no way x to the 4th and x to the 8th generates x to the 5th, 6th, and 7th as well. So we can eliminate B as a choice, and if you believe me in that, we can also eliminate A and C, remembering that sine of x would be all the odds, cosine of x is all the evens. If you multiply all the odds by 1x, you go back to being even. Then you add on 3x squared, so you're just going to get some total thing of evens. So 1 plus odd is even only. Therefore, it can't be this one because clearly we have a 5. This one is even times an x squared, which is also going to be even because you add 2 to everything, and then you add x squared here, which affects just one term, the x squared term. This is not going to go well either. So A, B, and C, none of those are going to work because we need 4, 5, and 6. What we do know that goes like 4, 5, and 6 is going to be e to the x. For the same logic, you can also eliminate this one, e to the x squared. And that's because if e to the x expands as follows, e to the x expands as follows, 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Making it x squared is going to make these further apart from each other, which is going to break the ability for it to be 4, 5, and 6. So I believe our answer here is D. Now I'll prove that one to you, and you're welcome to try expanding the other ones out using the memorized series. I guess I should leave that on the screen as to have for our next part. So I'm going to move the e to the x expansion up here and use that to generate this one. So we have e to the x times x squared. So we want x squared times 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 plus x to the n over n factorial. What we're doing is expanding x squared e to the x, by the way. That's what I did in power series. Now simplifying that a little bit, we could see that turns into x squared plus x cubed plus x to the 4 over 4 factorial, or 2 factorial rather, plus x to the 5 over 3 factorial, plus dot dot dot, x squared x to the n over n factorial can be re-represented as x to the n plus 2 over n factorial. So you can already see we're starting to get very close to what we want. These are pretty similar. In fact, they're going to end up being the same if we just change the value of n. Before we get to that, let's go ahead and remember that we do need to subtract off the other two terms. The terms we need to subtract are minus x cubed and minus x squared. If we subtract those, we will cancel the first two terms of our series. So now you can see we have the correct answer, x to the 4 over 2 factorial, x to the 5 over 3 factorial. Everything's working out. Now you might notice, hey, what's going on with these n's? This is n plus 3, this is n plus 1. However, this one says n plus 2 and n factorial. So we're off by a level of 1. And the truth is, if you think about it, what value of n would someone have to pick so that these numbers match? If n plus 3 is equal to 4, that means n is 1. Now that's different than our series because in the original one we called this guy n equals 0. So the fact that we're off by 1 means that our answers are allowed to be off by 1 in this way because we started counting at a different value. So our correct answer is D. I'm going to go over our notes in the next video, um, so hopefully that helped. And here's the total warm-up if you'd like to pause here and evaluate any one part.